Hi, this is Leetcode question number 2477. Minimum fuel cost to report to the capital. There is a tree, a connected and undirected graph with no cycle. Structure country network consisting of n cities numbered from 0 to n-1 and exactly n-1 roads. The capital city is city 0. You are given a 2D integer array roads where roads of I equal a of I b ai bi denotes that there exists a bidirectional road connecting cities ai and bi. There is a meeting for the representative of each city. The meeting is in the capital city. There is a car in each city. You are given an integer seats that indicates the number of seats in each car. A representative can use the car in their city to travel or change the car and ride with another representative. The cost of traveling between two cities is 1 liter of fuel. Return the minimum number of liters of fuel to reach the capital city. So for example here we have roads 01, 02, 03 seats equal 5. The output is 3 liters because representative 1 goes directly to 0 and representative 3 goes directly to 0 consume, so this car move from 1 to 0, and also the car can move from 3 to 0 and from 2 to 0. In each case it consumes 1 liter. So in total it's 3 liters. Here is another tree. The seats equal 2, so every car has 2 seats. It can carry 2 drives. So representative 2 goes directly to city 3 with 1 liter of fuel. So 2, the car here move to 3 and consume 1 liter. Representative 2 and representative 3 go together to city 1 with 1 liter of fuel. So after 2 reach here, the car can carry 2 persons. So here at 3 the car will carry 2 and 3 and it will move here, and until now we have 2 liters. Then representative 2 and representative 3 go together to the capital with 1 liter of fuel. So the same car moved to 0 and they arrived. And also for representative 1, the car will carry him to the capital with 1 liter. And also a car needed for from city 5 to 0 directly, and it will consume 1 liter. Here 6 to 4 we need the car will carry 6 to 4. Then at 4, so it's 1 liter. At 4 both of them will share the car and it moves to 0, and in total we will have 7 liters. Here the graph there is no one to travel to the capital city, and so the output is 0. Here are the constraints. Number of nodes less than or equal to 10 to the power 5. Seat is less than or equal to 10 to the power 5. So how can we fix this or how can we solve this problem? Let's take this example again. let's add more edges. Assume here we have 7, and also we have 8, and so as we said, we started at the leaf nodes, and we need to find the minimum, the total, the minimum of how many liters will be consumed in total. In every city we have a car, and every city will move towards the center car. So for example, we will start at 7 will move to 4, and this will consume 1 liter. And remember, the number of seats here equal to 2 in this example. So car 7 move to 4, it consumes 1 liter, and 6 move to 4, it consumes 1 liter. And here at 8 also move to 4, it consumes 1 liter. So at 4 we have 3 cars arrived, and these cars, each of them have 1 seats used and 1 seats free. So first of all, because there are 3 cars arrived, we know the last step consumed 3 liters. So if we have a global answer, we will add 3 to to the answer. Then at 4 we need to do the merge. So first of all, we need to we have 3 car arrived, so we add 3 to our answer, 3 liters. Then after that we have this car, which is number 4, and so we'll have 3 arrived from other nodes plus 1 car. And here we have the 3 cars, each of them used 1 seat. So by this, knowing that how many seats each car has, we can calculate how many riders already there. So in this case, for example, we have 3 cars, 3 seats available and 3 seats free. It means that there are 3 riders. And now here we have another car, which is number 4. So we have 4 cars and we have 4 seats used, and we have 4 seats free. But we need to merge people. 4 seats used means 4 riders. We need to use the minimum number of cars so that the amount of fuel consumed will be the minimum. So instead of having moving from here using 4 cars, we can do this 4 riders, and we can if we have 2 seats per car, then it means that we need to use only 2 cars. So from 4 we can send all the 4 people using 2 cars, and when arrive to 0 will know that 2 cars arrived to 8. So we will add 2 to our answer for this branch, and we will do the same for all other nodes. So So to solve this problem, again, we need to start, we need to use depth first search. We start from the capital and we travel all the way down to every nodes. And while traveling, we reach the leaf node. Then we return, in our function, we return information about the number of cars and the number of seats used. By this, at this node, so this node return to here, we can, like we do this for all the nodes, this branch, this branch, this branch. So at node 4 we can know how many seats used and how many seats are free, how many riders, and then we can do a merge and reduce the number of cars traveled to the parent node. And remember, at node 4, from the number of cars arrived to 4, we can update our answer by the number of cars. It means those cars consumes the number of cars liters in the last jump. Let's see the implementation. First of all, we need to create a graph from the given roads, and remember it's about a bi-directional road. So here we build the graph, and here we call the DFS function. DFS will return a pair of integers. This pair, first item is the number of cars used up to this node, and how many seats are used on those cars. The function takes the graph we built it that represent the tree, and the current node, the previous node or the parent, and the answer, global answers to update the value. Seats is the maximum number of seats. This is constant value, as you can see here. So we will pass the graph, and we start with node 0. Node 0, we assume it has no parent, which is -1, and our answer, the seats. Initially, free seats equal 0, number of cars equal 0, and we loop over all the neighbor of the current node, and for all neighbors we will check if the neighbor equal to the parent. We continue. We don't need to visit again. So here we start with 0. 0 neighbors is this, and this, but it will start with this as we are using DFS. Then DFS will call this and this and this. This will return, this will return, this will return, then this will return. So here for every neighbor we call the function DFS, and here we update the node and the parent node, and the total number of cars arrived to these nodes came from the neighbors. So this neighbor will return 1 number of cars, this return number 1 car, this return 1 car. So at 4 we have 3 cars arrived, so this value for 4 will be 3 cars. And also the function, remember, it returns the how many free seats, how many seats available. from that node. So here we have 2 seeds, one is used, so it return 1. Here we have also 1, here 1, so in total at 4. It will be accumulated to 3 seeds, 3 free seeds. Our answer will be updated plus equal number of cars, because one car, let's say here 1 car, and it's at the last jump, it will consume 1 liter. If there are 2 cars, it will consume 2 liters. So our answer plus equal number of cars. Now after that, we need now to prepare the results for returning. So at 4, we need to consider the car at 4 plus the car arrived, and we need to do calculation in order to merge the cars. So we increase the number of cars by 1, which is the current node, and also number of seats available equal seats minus 1, because this node, we assume it take 1 seat from this available car. So the total number of free seats equal the total number of free seats for all the nodes arrived to this node plus a free node for this car. Now the number of riders, how many people used these cars equal to number of cars multiplied by seats. This will give us all the number of seats in all cars minus total number of free seats. It will give us how many used seats, and each seat is used by 1 representative or 1 person, so this will give us the number of riders. Now if number of rider mode seats equal 0, it means that we can divide those riders equally into the number of rides divided by seats, and it means that also we can distribute the riders into a cars, and there will be no free seats after that. Other than this, there will be free seats, which equal to the total number of seats minus number of, or this is the seats, this constant. So number of riders mod the seats, the last car will contains, let's say, one rider, so there will be also 1 free seats. The number of cars that will be used for all of these riders, so if the free seats equal to 0, we can do this directly, number of rider divided by seats. So if we have 8 riders and seats, every car has 2 seats, then we can use 4 cars. But if we have 7 riders and the number of seats 2, we can use again 4 cars, but 3 of them are full and 1 of them has only 1 person. So now we calculated the number of cars and we know how many seats are free. We return the value to be handled by the parent node.